in this diagram you can see that this is our memory unit, which is basically our RAM, right? And this is our CPU. The CPU is connected to the memory unit through the data bus. So that is one wire or one cable that connects our CPU to the memory unit. The other cable that is connecting the CPU to the memory unit is the address bus, and the third one that is connecting the CPU to the memory unit is the control bus. So we have three buses which are basically connecting the CPU together to the memory unit. All three buses are being used for different purposes. These boxes inside the CPU, this is a register. So all of these boxes are registers. Now there is only one general purpose register, and that is the accumulator. So the accumulator is also known as the general purpose register. Every other register in the CPU is called the special purpose register. So program counter is a special purpose register, current instruction register is a special purpose register, index register is a special purpose register, memory data register is a special purpose register, MAR is a special purpose register, which is MAR stands for memory address register, but the accumulator is a general purpose register. In our memory, this is the program that is going to get executed. These are data values that are lying in the memory, and there is the operating system lying in the memory. Okay, so at this point in time there is program in the main memory, there is also data in the main memory, and there is part of the operating system in the memory. So the program that is currently in use, the data that is currently in use, and operating system currently in use, all of these three are present inside the RAM. Remember, this memory unit is our RAM, right? So a RAM at any time contains program currently in use, data currently in use, and operating system currently in use. So this is the program that is going to be executed. Let's take a look at how this works. How is this program executed? The program counter holds the address of the next instruction that is to be fetched into the CPU, and in this case that instruction is lying at location number 1 in the main memory. So the program counter holds the value 1 pointing to this instruction. When the next clock cycle comes, the program counter value is copied into the MAR. So the MAR now holds the value 1. Because the MAR is connected to the address bus, instantly that value 1 is updated on the address bus. So the address bus is pointing to this location right now because the address bus contains the value 1 right now. Okay, now when the control unit sends a read signal through the control bus, so the control unit sends a read signal through the control bus to the memory unit, then this instruction will be read from the main memory, and at this point this instruction is going to flow through the data bus. LDD7 will flow through the data bus and it will come into the MDR. So LDD7 will be copied into the MDR. When the next clock cycle comes, this instruction which is lying in the MDR is now copied into the CIR. So LDD7 is now copied into the CIR. At this stage the fetch cycle has been completed. Now the program counter increments itself by 1 to point to the next instruction that is going to be fetched. So the value of the program counter becomes 2 instead of 1. Program counter value is incremented by 1. So the value of the program counter becomes 2. At this stage the instruction in the CIR needs to be decoded. Now there is a small circuit inside the control unit which is called the decode unit. I have not drawn it here, but there is something called a decode unit inside the control unit. That decode unit is going to work on this instruction, and this instruction has two parts. LDD7 has two parts. This is called the opcode and this is called the operand. So the control unit works on the opcode, the decode unit works on the opcode to try and figure out what to do with this instruction. What is this instruction all about? Once the decode unit has analyzed the instruction, the decode cycle is complete. Now this instruction is ready to be executed, so the execute cycle is going to begin. The LDD instruction is basically a load instruction which says that go to location number 7 in the main memory, go to location number 7, and the value lying in the location number 7 has to be fetched and loaded into the accumulator. So this is what is going to be executed now. So as the first step, when the next clock cycle comes, this value inside this value that is part of the instruction, this memory location 7 is copied into the MAR. So the MAR will now be overwritten with this value 7. So the MAR now holds the value 7. As soon as the value 7 is copied into the MAR, it is instantly reflected on the address bus. So the address bus is basically pointing to this location right now. The address bus is pointing to this location right now in the main memory. So now the control unit sends a read signal on the control bus to the memory unit, which basically means that read this value from location number 7, read this value, and this value is read and copied onto the data bus. So the data bus is now carrying this value 12. It is going to be taken to the MDR. So the MDR is now going to be overwritten with this value 12. So the value in the MDR becomes 12. Now when the next clock cycle comes, the value from the MDR is copied into the accumulator. So the accumulator is now going to be loaded with this value 12. At this point in time, the execute cycle is complete. The instruction LDD7 has been executed. Now that this instruction has been executed, the next instruction has to be fetched from the main memory into the CPU. So the address of the next instruction is held by the program counter. So this value which is held in the program counter, right, this value 2 is now copied into the MAR. As soon as this value is updated in the MAR, that value is instantly reflected on the address bus. So the address bus is instantly updated. Now the address bus is pointing to this location in the RAM. This is where our next instruction is stored. So this is the instruction that has to be brought into the CPU. So in the next clock cycle, when the control bus sends a read signal, when the control unit sends a read signal on the control bus to the memory unit, this instruction is read from the memory unit and it now flows through the data bus. So add 8 now flows through the data bus and it is copied into the MDR. When the next clock cycle comes, this instruction in the MDR is copied into the CIR. So at this stage the fetch cycle has been completed. So fetch cycle has been completed. Now that this instruction has been fetched, the value in the program counter is going to be updated, so that program counter now points to the next instruction that is going to be fetched. So the value of program counter is incremented by 1 and it now becomes 3 instead of 2. Once the program counter has been updated, the instruction in the CIR is decoded by the decode unit, and then this instruction is executed. Now once this instruction has been decoded, it is found out that this instruction is saying that go to location number 8 in the main memory, go to this location, take the value, copy the value in that location, and then bring it into the CPU and add it to the value that is already there in the accumulator. So add this value 8 into the value that is already there into the accumulator. So 8 is going to be added to 12, and the answer 20 is now going to be saved into the accumulator. So that is what this add 8 instruction is all about. Now this instruction is going to be executed. So now that this add 8 instruction is going to be executed, the execute cycle is going to begin. So the execute cycle is going to begin. Okay, when the next clock cycle comes, as a first step, this address value in the instruction is copied into the MAR. So the MAR value is now updated to 8. As soon as the value in the MAR is updated, that value is instantly reflected on the address bus. So the address bus is now pointing to this location. Now in the next clock cycle, when the control unit sends a read signal on the control bus to the memory unit, then this value at location number 8 is read from this memory unit, and it is copied into the data, it is copied onto the data bus. So from the data bus, this value 8 is now going to flow and be copied into the MDR. So when the next clock cycle comes, this value, this data value in the MDR is transferred to the ALU. So this value is transferred to the ALU, and the ALU is going to add this value to the already existing value in the accumulator, and the result is saved into the accumulator. At this stage, the execution of the add 8 cycle is complete. So we've completed the execute cycle. Now the next instruction has to be fetched into the CPU. So the next instruction that has to be fetched, its address is found in the program counter. So the program counter is telling us that the next instruction is lying at location number 3 in the main memory. So now the fetch cycle for this instruction gets started, right? So the fetch cycle for instruction which is lying at location number 3 in the main memory gets started. In the first step, this value in the program counter is copied into the MAR. As soon as the value in the MAR is updated, that value is also updated on the address bus, and it is instantly reflected on the address bus. So the address bus is now pointing towards this location in the main memory. Now in the next clock cycle, at this point, the control unit through the control bus sends a read signal to the memory unit, and when the memory unit receives that signal, that value is read from, that instruction is read from the main memory. It is copied onto the data bus. So now this instruction store 9 is going to flow towards the MDR, and it's going to be copied into the MDR. Okay, once this instruction has been copied into the MDR, in the next clock cycle it is going to be copied into the CIR. At this stage, the fetch cycle for this instruction has been completed. At this stage, the fetch cycle for this instruction has been completed. So now this instruction is going to be decoded by the decode unit. Once this instruction has been decoded, it is found out that this instruction is saying that load the value that is already there in the accumulator, take this value from the accumulator and store this value into location number 9 in the RAM. So that is what this instruction is saying. So once this instruction has been decoded and the decode cycle has been completed, this instruction has been analyzed, now the execute cycle is going to begin. So now the execute cycle is going to begin. Of course, the program counter first increments itself to point to the next instruction that is going to be fetched. So the value of program counter is going to change from 3 to 4. The program counter is going to increment itself by 1. Once the program counter has incremented itself, the execution cycle of this instruction is going to begin, right? So the store 9 instruction is now going to get executed. As a first step, this value 9, which is part of the instruction, this address 9 is copied into the MAR. As soon as the value of the MAR is updated, the address bus is also updated. So the address bus is immediately updated with this value 9. So right now the address bus is pointing towards this location in the memory. Okay. So now, because the value in the accumulator has to be stored at this location, right? So this value has to be stored at this location. That value must first be transferred to the MDR, because the accumulator is not directly connected to the memory unit. Therefore this value 20 is going to be copied into the MDR. So now that this value has been copied into the MDR, it is now ready to be transferred to the memory unit, to the RAM. So this time the control unit is not going to give a read signal, rather the control unit is going to give a write signal through the control bus. So the control unit is going to give a write signal because we want to write to this location in the memory unit. So when the control unit is going to send a write signal on the control bus, this value 20 in the MDR will flow through the data bus to this location 9, and it is going to be saved there. Now that this value 20 has been stored in the memory unit, the execute cycle is complete. Next we are going to fetch the next instruction, and the next instruction that is going to be fetched is the instruction whose memory location is stored in the program counter. So the program counter is telling us which next instruction is going to be fetched, and the program counter is saying that this is the next instruction in the memory unit which is going to be fetched. So now the fetch cycle is going to begin. As a first step, this value in the program counter is going to be copied into the MAR. Now as soon as the value of program counter is copied into the MAR, this value is also updated instantly on the address bus. So the address bus is now pointing to location number 4. Now when the control unit is going to send the read signal over the control bus, this instruction is going to be read from the memory. It is going to flow through the data bus, right? So this instruction is going to flow through the data bus into the MDR, and from the MDR this instruction is going to be copied into the CIR. So the fetch cycle is complete. Now that this instruction has been brought into the CIR, the fetch cycle is complete. The program counter now increments itself to 5 to indicate that the next instruction that is going to be fetched is going to be from memory location 5. Now that the program counter has incremented itself, the decoding of this jump instruction takes place. So the jump instruction is decoded by the decode unit, and when it is decoded, when this instruction tells us that the next instruction that is going to be fetched is going to be fetched from location number 25 in the memory. So this jump instruction is telling us that the next instruction that is going to be fetched is the instruction lying at location number 25 in the memory, whereas the program counter is telling us that the next instruction to be fetched is instruction number 5. However, this instruction, when this is executed, it is going to it is saying that, you know, the next instruction to be fetched is the instruction that is lying at location number 25. Obviously we can't see location number 25 here in the memory unit. I haven't drawn it here, but it's going to be somewhere down here, location number 25. Anyways, when this instruction has been decoded, this instruction is going to get executed. When the jump instruction gets executed, this value 25 is now copied into the program counter, because jump instruction is saying that whatever value I have in my instruction is the value of the address of the next instruction that has to be fetched. So this is what is basically going to happen when the jump instruction is going to execute. This value 25 in the instruction is going to be copied into the program counter when the jump instruction is executed, because the jump instruction says no matter what the value in the program counter, the next instruction that is going to be fetched is going to be instruction lying at this location. That is why this location is copied into the program counter, and now the program counter is telling us that the next instruction that is going to be fetched is going to be at location number 25 in the memory unit. I hope you understand the working of the I hope you understand how this cycle works. This fetch decode cycle, fetch decode execute cycle works inside the computer. Okay, let's quickly answer these questions. How do the contents of the program counter change during the fetch cycle? Now during the fetch cycle, if you remember, the program counter increments itself by 1 to find the address of the next instruction that has to be fetched. So this is our answer. But how do the contents of the program counter change during the execute cycle? Well, during the execute cycle, there is only one instance, one time when the value of the program counter changes, and that only happens if there is a jump instruction that is executed. So when a jump instruction is executed, it is during the execution cycle of the jump instruction that the value of the program counter changes. How do the contents of the accumulator change during the fetch cycle? The contents of the accumulator, if you remember, you know, the fetch cycle that we just went through, the contents of the accumulator don't change during the fetch cycle. Nothing happens to the accumulator during the fetch cycle. They do not change. Okay, but how about the execute cycle? Do the contents of the program counter change during the execute cycle? They are so during the execute cycle, data values are updated as a result of load instructions, and also as a result of arithmetic operations, So let me just and as a result of arithmetic operations. Remember, the add instruction was, you know, able to, when we executed the add instruction, the already existing value was updated. So data values are updated simply because of the load instructions, and also if there is an instruction like the add instruction or the subtract instruction, that also updates data values during the execute cycle. Okay. How do the contents of MDR change during the fetch cycle? During the fetch cycle, the MDR holds the instruction that is being fetched. So during the fetch cycle, the MDR temporarily holds the instruction being fetched from the memory. So that's what happens during the fetch cycle, right? The instruction is being fetched from memory and it is temporarily stored in the MDR before it is passed on to the CIR. However, during the execute cycle, data being fetched from memory or data being fetched from memory into CPU or data being stored into memory from CPU is temporarily held by MDR, is temporarily held by MDR, right? Is temporarily held by MDR. So that's how the contents of the MDR change during the execute cycle. How do the contents of MAR change during the fetch cycle? During the fetch cycle, the program counter value is transferred into the MAR, right? So program counter value is transferred, or you should say it is copied into MAR during the fetch cycle. So basically the address of the instruction, the address of the next instruction that is to be fetched from memory is basically copied into the MAR. And during the execute cycle, the address held in the instruction is copied into MAR. At a particular point in a program, the program counter contains the value 200. State the expected value contained in the program counter after the instruction held at location 200 has been fetched. After the instruction held at location 200 has been fetched, the program counter value should be 201, because you've just fetched an instruction and now the program counter should increment itself by 1 to point out to the next instruction that is to be fetched. So you just fetched an instruction from location number 200. The next instruction that is going to be fetched is found by the program counter by incrementing itself by 1. So this is the explanation. The program counter increments itself by 1 to find the address of the next instruction. So that is why the value changed from 200 to 201. Okay, let's solve part 2. Part 2 says after the instruction is processed, the value in the program counter is 180. So what he is saying is that after when part 1 when we solved part 1, we said that the value of the program counter changed to 201, right? So the instruction that had currently been fetched was what? Was instruction that was located at 200. After this instruction had been fetched, after this instruction had been loaded into the CIR, the program counter changed its value to 201. Okay, but then after that instruction in the CIR was processed. Okay, so this instruction which had been fetched into the CIR, after this had been fetched into the CIR, at this point the value of program counter was incremented to 201, right? But then this instruction which was fetched from location 200 was executed, and the end result was that the program counter value changed from 201, it changed to 180 as a consequence of the execution of this instruction which was held in the CIR. The program counter value changed to 180. Why did this happen? Well, this only happened because the instruction that was fetched from location number 200 was a jump instruction, and the jump instruction must have held this address 180. So when this instruction was executed, this value in the program counter had been updated. So this diagram shows a program loaded into main memory starting at memory location 7A. So this here is basically a program, right? So these must be instructions, and we can see that each instruction is made up of 4 hexadecimal digit. So each instruction is made up of 4 hexadecimal digit, and we know that one hexadecimal digit, when it is converted into binary, is written down as 4 bits. So if we wanted to write this 2, which is in hexadecimal form, into binary, then we were going to write it down as 4 bits. Okay, and this 1 was also going to be written down as 4 bits. So each hexadecimal digit is always converted as 4 bits. So this 5 is going to be written down as 0101, and this 0 is going to be written down as 0000. So this is the same instruction 2150. Now it has been written down in binary form. So the question he's asking is how many bits are used for each main memory location, and as we can see that each memory location has 4 hexadecimal digits, and for each hexadecimal digit we need 4 bits of memory. For each hexadecimal digit we need 4 bits of memory. Therefore, for one memory location we have 4 hexadecimal digits, which basically means we are going to need 16 bits per memory location. Okay, let's now solve this trace table, and right now this table shows us that the program counter holds the value 7A, which basically means that the program counter is telling us the next instruction that is going to be fetched into memory, right? That is what the program counter is telling us, and that location is 7A, right? Okay, then the next instruction that gets executed is this one. The contents of program counter are copied into MAR. What are the contents of program counter right now? They are 7A. So this value 7A is going to be copied into the MAR. Remember, this is the column for MAR. So this is copied into, this value is copied into the MAR. Okay. Once this instruction has been executed, this is the next instruction that gets executed, and this instruction, the contents of program counter are incremented by 1, and the value is saved into the program counter itself. So where is the value going to be stored? In the program counter. Okay, so when we have what is the current value of the program counter? The current value of program counter is 7A, and we are going to add 1 to it. Now 7A can be written down as, in binary form, 7 can be written down as 0111, and A can be written down as 1010. Now in binary form we have 0111 1010. When we add 1 to it in binary, 1 plus 0 is equal to 1, then we have this 101110. So this is our number in binary form after 1 has been added to it. So this is the number that we have, 01111011. Now we want to convert this number back into hexadecimal. So when we convert this 1011 into hexadecimal, 1011 is 1, 2, 4 and 8. This equals 11, right? This equals 11. When we apply the weight, this equals 11, and 11 in hexadecimal is written down as B. This is 7. So when we add 1 to 7A, it becomes 7B. So this value 7B is going to be saved in the program counter. So in this column we are going to add 7B. Okay, the next instruction to be executed is this one, which says that, so we have a double bracket on this side, right? And this is what is indicated here. Okay, let's just try and understand what this instruction means. See, this means program counter. This means program counter, and when we say this, then this means contents of program counter. Then this means contents of program counter. So now we are saying what value is held inside program counter. Likewise, when we say MAR, then that simply means the memory address register. Then that simply means the memory address register. But when we say MAR surrounded by these square brackets, then that means contents of memory address register. Contents of memory address register. This means the value held inside MAR. Okay, to solve this, let's solve the inner bracket first. Let's solve this inner bracket first. Okay, which basically says the contents of MAR. And what are the contents of MAR right now? The contents of MAR right now are 7A. So the answer to the inner bracket is 7A. So once we've solved the inner bracket, the answer to the inner bracket is 7A, and then there is another bracket surrounding 7A. This is the outer bracket. Once we have solved 7A, now we want to solve the outer bracket. So the outer bracket is around 7A. So now we are saying the contents of 7A, and the contents of 7A are 2150. So this time the value that is going to be copied into MDR is going to be 2150. Okay, and finally the contents of MDR are being copied into CIR. What are the contents of MDR right now? They are 2150. So these are being copied into CIR. So the value of CIR becomes 2150. Okay. Finally, we also have to indicate when do these buses get updated. So this should be fairly simple. When the contents of program counter are copied into MAR, when the value inside the program counter is copied into MAR, that value is instantly updated on the address bus. So at this moment, when this instruction is executed, the address bus is updated. And secondly, when this data value, which was 2150, which was lying in the memory, it is when this instruction, sorry, this is not a data value, this is an instruction, right? When this instruction is brought into MDR through the data bus, right, on this instruction, right, when from the memory location that instruction is being fetched into MDR, that is when the data bus gets activated. So I hope you understand this question.